So welcome to my YouTube channel SADHIK Physics. So you can learn the physics very easily. So through my channel, no. So which who are preparing for competitive examinations and board examinations, no. So definitely my videos are very helpful, no. Whenever you are watching these videos, no. So please take out your books, one note and try to copy whatever I am discussing, no. In this chapter, no. Therefore, in my videos, no. So I will be explaining the concepts very detailedly and the formulas which are involved, and will be solving all different type of model questions, no, which can be expected to ask in the examinations, no, like competitive examinations, NEET, IIT-JEE and advanced, no. So like this I have made so many videos, no, please go through it, no. So let us come back to my today's topic, that is photoelectric effect, no. Photoelectric effect. On this topic only, photoelectric effect, no, Einstein got the Nobel Prize for this one, no, clear. And also quantum theory, like right, E is equals to h nu and hc by lambda. Quantum theory, right, so was successfully utilized by this Einstein's, no, to explain this photoelectric effect. And from this experiment only we came to know that light is having some particle nature also. That particle is nothing but a photon, that I already discussed in my past video. Please go through it about the photon. I already discussed onto this, right. So we will discuss. Please those who did not subscribe, please subscribe to my channel now, clear. So now let us go for this photoelectric effect. On this topic only, photoelectric effect, no, Einstein got the Nobel Prize for this one, no, clear. And also quantum electric effect, no. So what is mean by this photoelectric effect? Photoelectric effect. In the name itself is there photo. Photo means what? Light, right. So therefore light, what it is doing now? It is showing the effect on the electrical. Therefore electrical means what? Current. Therefore it is showing the effect on the current onto this one, right. Current means what? We require the electrons, right. So therefore how that light is showing the effect on the electrons now. So electrons like how it will be there. So the emission of the electrons should be takes place onto this, right. So we can emit the electron from the material, no. Therefore by applying very large amount of electric field, no, so that the electrons can be emitted from the metal surface, no, clear. And also we can heat the substance, no. This we can call it as like a thermo-ionic emissions onto this. If you heat also, it will the electrons will gain the energy and it will go to the excited state, no, and it will come out from the atom onto this, right. Even light also, therefore if light is falling, so therefore what will happen now? It is going to emit the electrons. This was observed by Hertz, right. So first it was observed by the Hertz, right. So what he did now on the zinc plate, no, therefore he incident ultraviolet rays. So therefore this ultraviolet rays is incident. So therefore he identified that when ultraviolet rays are incident onto this one, no, it is constitutes a like certain amount of current. Not only the Hertz, no, Hallwag. So he also observed that, no, therefore so whenever there is a light on the zinc plate, no, therefore whenever there is a zinc upon to the zinc plate, like a negatively charged zinc plate, no, if a light is incident onto this one, which light now? Ultraviolet rays, no. If incident, the charge on the zinc plate, no, negatively charged means what? More number of electrons are present. If light is incident, no, the negativity of this charged part, charge on the zinc plate, no, was decreasing. So slowly it is coming to the neutralize, and it is also it is like a positive charge. Means what? Therefore zinc plate is already negatively charged. Means what? So it is gaining like a decreasing the positiveness means, so emitting the electron, loss of electrons, and coming to the zero means, so how many electrons are gained? No, that many electrons are lost. Gaining positive charge means what? More amount of electrons are losing now. That means when light ultraviolet ray is incident onto this one, no, so it is going to emit the electrons, right. So Leonard also he said that when upon to the plate, no, so if you incident a ultraviolet rays, no, therefore it constitutes a again current. So which will move from cathode to anode. If light is incident on the cathode, current will be conducting, no. If a light is incident on the anode, so therefore current will be not constitute onto this, right. So therefore Leonard, so he also observed that there is a one cathode plate and anode plate, no. Upon to the cathode, so suppose if you are incident on a zinc of ultraviolet rays, no. So therefore here electrons are moving and it is reaching to this point, no. That means, so loss of electron, gain of electron, no, therefore constitutes a current, current will be flowing. Suppose if you are incident the light on the anode onto this one, no. So definitely, so therefore here whatever the electron which is emitted, it will go back and come back to this one, no. Therefore there is no current, it will be observed onto this. In this way, these all the three experiments, no. So these all the three persons, no, observed that if a light ray is incident on a metal, no, so definitely there is a emission of electrons is taken place, no. So we'll study detailedly about this emission and photoelectric effect experiment onto this one, no. Then, so what are the results? So how that results are explained by the Einsteins, no, and we will discuss very detailedly. So please stay tuned to this here. So we'll discuss, no, what is this photoelectric effect or photoelectric experiment. Effect experiment. So what is this photoelectric effect experiment, no? Therefore you can take it as like one discharge tube onto this one, no. So one tube you can take it here, no. This tube, so this is one discharge tube, no. So upon to in this tube, no, therefore there is no right, the pressure, I mean the air inside this one, no, it will be pumped out onto this, so that if any air particle is present inside the tube, no, therefore it will be electrons will get collided, so therefore electrons will not move from this point to this point. So it is maintained as very low pressure here, no. So therefore here this is closed, and this one metal plate, no, it is connected to one battery here, no. Therefore here it will be negatively charged and positively charged, no, and there is a one ammeter. So even you can connect one rheostat to adjust this one, no. So therefore here, so this is negatively charged plate, here positively charged, I mean positive plate onto this. Clear? So in this way, now what we are going to do now, so here this cathode plate, no, anode plate is very far away onto this one, no. Here completely vacuum or some small particles are there, no. So what we are going to do now, so this now what you will observe now, these two particles plates are very far away, there is no connectivity between them, no. Therefore this ammeter now will show 0 reading now, because there is no conductivity. What I will do, I will goes on increasing this voltage. What I will do now, I will goes on increasing this voltage. So whatever may be the voltage you are applying now, because plates are very far away, we are not applying the electric field very near to this. So as it goes on increasing onto this one, no, there is no chance of electron is going from here to here. So therefore the current will be showing certain amount of, current will be showing as like a 0 reading onto this. So whatever may be the potential, even 10,000 volts now you are applying, no, so there is no current, it will be flowing, means there is no loss of electron, there is no gain of electron now. That means this tube now it is not conducting anything. Clear? Huh? So now there is no current, it is flowing now. Now what I will do now, so upon to this plate now, upon to this plate, so therefore there is a light is allowed to incident onto this. So there is a light is incident onto this. So this is the light. When light falls on this plate now, therefore what is going to happen now, when the light is falling on this plate now, so you will observe interesting thing now, when light is falling, so here there is a electron emission will be taken place now. Electrons are emitted now, so electrons are slightly moving with certain speed onto this one now, right, because emitted electron will maybe having certain amount of energy. Now what I will do now, I will apply certain amount of potential here now. Slowly I will increase very low amount of potential I will apply, you know. So these electrons which is emitted, so therefore it is not having that much sufficient energy to go there now. But slightly if you are increasing the potential, no, there will be electric field is created. These electrons are attracted toward this side. So these electrons know what is happening now, it is reaching to this point. That means this, so there is a light is incident onto this. electron was lost from this plate no, and this electron is gained to this plate. That means here there is a loss is there and here it is a gain is there. That means electron is moved from here to here onto this. Clear? So when electron is moving, so what you can see that now there is a milliammeter you have to use it now. Therefore, this ammeter reading will show certain amount of current here now. Will show certain amount of current. That means what will happen now? Before there is no light is falling now, so therefore there is no current now. But once the light is falling, there is a current is there. Means, so definitely electrons are emitted onto this. And not only emitted, these are reached to this point now, right? These electrons which are emitted, these electrons will call it as like a photoelectrons. What are these now? Photoelectrons. And the current due to this one now, we can call it as like a photocurrent. Photocurrent. Understood? No? So that means from this experiment, no, you understood that. So light falling onto this one, no, so it is emission of electrons is taken place now. Now we will study. So we want to calculate it now. Light means is having lot of properties now. So in this one now, what properties is affecting the emission of electrons onto this? So we can study effect of light, that is intensity. We will study the intensity of light which is showing the effect on the emission of electrons onto this. Also we will study about the frequency of light. These are the two properties. No, we will change it and we will observe that emission of electrons. Here one more important point we require. No, therefore we want to calculate the kinetic energy of these electrons, maximum kinetic energy. How to calculate now? We know that in a previous videos also I discussed so many times now, kinetic energy is nothing but a electron volt. Therefore, this also kinetic energy. We want to calculate potential difference. So therefore, these electrons which are emitted now, it will be having some kinetic energy. Therefore, what I will do now, I will apply certain amount of reverse potential here now. So what is this reverse potential now? I will apply here now. There is a one reverse potential I am going to apply. Let us see here now. This is a reverse potential. This is an cathode now. So I will convert into like this. So reversely I am applying now to this. Therefore, what will happen now? This will become like a positively charged. This will become like positive terminal, negative terminal. Negative terminal will be repelled by the electrons now. Therefore, this emitted electron now, what it will do now? It will go toward this side. So many electrons now will come back because here negative is there. So it has to overcome onto this one. Slowly I will increase onto this one now. Okay, even though most of the electrons are coming back, but some electrons which are having very larger energy, it will be reaching to this. It is overcoming the electric field, right? So therefore, what we want to do now, we will slightly increase the potential onto this now, slightly. So therefore, what will happen now? The electrons which are coming here, so therefore it may not reach to here, no, it come back. So come back means what will happen now? There is no electrons are reaching now. Therefore, current will be shows certain zero reading. We are applying the reverse potential where current is zero. Therefore, minimum reverse potential we have to apply so that the current will be zero. Current will be zero means what? Electrons are not reaching to the other terminal onto this. Clear? The minimum potential we will call it as like a stopping potential. Stopping potential. Understood? Stopping potential, or we can call it as like cutoff voltage onto this one, minimum voltage. Clear? So this stopping potential, what it will do now? It will measures not kinetic energy of all the electrons, no, it will measures. So this minimum potential which is there now is called stopping potential or cutoff voltage. So this will measures so maximum kinetic energy of the electron. Maximum kinetic energy of electron will be calculated. Not energy of all the electrons will not be calculated, no, because some electrons are reaching here, going back, no, but some maximum electron will be there, maximum energy will be there, it will be reaching now. Therefore, here minimum is there, no, we are calculating. This stopping potential will reach the maximum kinetic energy of the electron. So therefore, we can rewrite it as maximum kinetic energy of an electron, maximum kinetic energy. So you can write it at half m v max square, that is nothing but E into V naught. So this is the reverse potential we are applying onto this one now, so that no electrons are reaching. not maximum, minimum potential I am applying onto this, right. So, this is we can call it as like a stopping potential or cutoff potential, clear. So, these are the information is required. Now, what we will do now, we will study that, we will study the effect of intensity on the emission of electron and kinetic energy of the electron, and the effect of frequency on the emission of electrons and kinetic energy of the electrons. Now, we want to change the intensity. Intensity, how we are going to change it now? Intensity, right? How we will change it now? Let us see. So, there is a one plate is there, no? Right. So, therefore, how you will change this intensity? Right, listen carefully. So, we studied that, right. So, here I want to change the intensity, I want to change the frequency. First, let us see effect of intensity, effect of intensity, clear. So, effect, if you want to study effect of intensity, frequency should be kept constant. Frequency what should be there? It should be kept constant. You understand, no? So, how I can change the intensity now? Intensity of the light which is falling here now. So, this intensity of the light which is falling here now. So, this can be changed. You know, intensity, what is the formula? Intensity is nothing but power by area. This I already discussed in my previous videos also. So, therefore, power by 4 pi r square. R square. Intensity is inversely proportional to the square of the distance. What I will do now? What I will do? Right. So, what I will do now? Here there is a source of light, I am going to keep it, no? There is a source of light, no? What I will do? If I move away from this one, no? Intensity is decreasing. If I move this source toward this side, no? Intensity is increasing onto this. Clear? So, therefore, if I move away, intensity is decreasing. If I move toward this side, intensity will be increasing. So, in this way, by moving the source of light, no? I can change the intensity onto this. Now, you understand, no? So, therefore, by changing the intensity by keeping the frequency constant, so if you repeat this experiment onto this, now I am calculating, so calculating current and so also therefore, here stopping potential also you are calculating onto this. So, what will happen now, right? So, you will observe this one, no? By changing the intensity, what we will observe? We will observe one very important concept here, no? Listen carefully. So, what we are going to observe here now, by changing the intensity but frequency is kept constant. So, we will draw the current, therefore, current ammeter no, and voltage one no. Therefore, we will draw the graph here no, this graph variation, right. So, this graph no. So, how the graph it will be there? Listen carefully no. So, here now, so this is your current and this is your voltage. So, now I will keep one intensity I1. Therefore, for I1 there is a for certain amount of intensity, frequency is kept constant now, frequency is constant in this one now, is constant. So, if one intensity is there no, therefore, this intensity what it will do no, it will emit the electrons, these electrons no, these electrons are emitted now. So, now while slightly increase this voltage, what will happen now, this emitted electrons no, maximum it will be coming onto this. If goes on increasing, no, there is no change in the current onto this. That means, so emitted electrons will be there by slightly increasing the potential, slightly increases, therefore, it will be comes to the saturation onto this. Clear? That means, increasing this potential will not make a emission of electrons onto this. So, which are emitted electrons, no, which is trying to pull by changing the potential onto this. So, therefore, this is I1 is the intensity, and next other one now, another I2 intensity we are changing no. So, suppose again I am increasing the intensity, so therefore, this is your I3. If I am increasing the intensity, so what will happen now, this current, this we can call it as like saturation of this one, no? Saturation current, right? So, as increasing the intensity, that means I3 is greater than I2 is greater than I1. That means what you are doing now, intensity is increasing. When intensity is increasing, what is happening now? Current is increasing now. So, that means what you understood now, if intensity is increasing, so therefore, current is also increasing. Clear? So, what do you understood now? If intensity is increases, current also increasing. So now what we will do, we'll see, we'll calculate the stopping potential, we'll connect it to this one now, then we'll apply this one now, then one surprising result you are going to see it now. So whatever maybe the intensities are there now, therefore you will be seeing the some stopping potential and stopping potential, and so for all this one now the stopping potential was same only. So that means if you are increasing the intensity, so current is increasing, means emission of photoelectrons is increasing, photocurrent is increasing, but so due to different intensities the stopping potential is not changing. That means stopping potential is constant only. That means stopping potential is constant means what? Kinetic energy is constant or kinetic energy is not changing. That means what you can understand now, so kinetic energy or stopping potential does not depend upon the intensity. From these 2 points now you can understand here now, from this graph you can understand, from this graph now you can understand 2 points. So first point is what? As intensity is directly proportional to photocurrent, or emission of electrons no is because of due to the intensity. So therefore stopping potential or cutoff voltage or kinetic energy of electron is independent of intensity. Right? So these are the 2 points now you can understand from this graph now. So what you can understand? So emission of electrons is because of due to the intensity. Therefore intensity increases, so current will be increases. Emission of photoelectrons will be increases. So current and intensity. How the graph it will be there now? Graph it will be like a straight line. So this is the current, photocurrent or emission of electrons. This is about the intensity. So if intensity increases, emission of electrons also will be increases. So that means emission of electrons is purely depends upon the intensity. Emitted electron kinetic energy is there no, does not affected by the intensity. Right? If you draw the graph between the intensity and stopping potential or intensity and kinetic energy, so therefore here it is connected on kinetic energy and intensity. So what you will get it now? You will get a one straight line, constant, does not change. Clear? Right? So therefore these are the 2 points now you can learn from this point. Clear? So these are the concept. This is one effect of the intensity. Clear? So now we'll see. Right? So now we'll see one more concept, no, that is effect of frequency on the photocurrent. If frequency is changing, no, compulsory intensity should be kept constant. Intensity should be kept constant. Clear? So intensity is constant, but what you are changing now? We are changing the frequency. Again the question doubt, no, how you will change the frequency? You see that VIBGR light is there, no, so violet, indigo, blue, green, yellow. So in that one, no, red color is having larger wavelength, so blue color is having lower wavelength. Therefore wavelength of the red color is greater than wavelength of your blue color. But wavelength is inversely proportional to the frequency, because C is equals to wavelength into frequency, and C speed of the light of all the light rays, no, it will be the same. Frequency is inversely proportional wavelength. So therefore frequency of your blue color is greater than frequency of your red color. So that means, so you can understand, therefore if you are shifting from red color to blue color, the frequency is what is happening now? Increasing. Or if you are going for ultraviolet rays, no, therefore again X-rays and gamma rays, no, there will be having like a greater frequency onto this. Clear? So therefore by changing the color, you can tell that you can change the frequency. Clear? Now you understand. Now again the same experiment, no. So if you observe it, no, therefore how the graph it will be there. Very interesting graph, no. So interesting one, no. Listen carefully. So this is your current and this is your potential. Now in this graph, now what you are keeping now? We are keeping the intensity. Intensity is kept constant. What we are doing now? We are not changing the intensity. Intensity is same. So therefore different frequencies are there. So what you will observe now, you will observe that therefore here with the certain constant intensity there is a current, it will be there. So you will see that there will be a almost this is not there. So for your level, therefore I am drawing these 3 lines. So therefore these are the different frequencies, no. So if you are changing the frequency but the current, it will be the same. What you understand now from this one, no? If you are changing, these are the different frequencies, no, but the current is not changing. That means so current is independent of the frequency. That means photocurrent is independent of a frequency. Clear? Is an independent of the frequency. That means photocurrent. That means emission of the electrons, no, so was not dependent on the any frequency onto this, or by changing the frequency. So therefore there is no effect on the photocurrent onto this. Let us see what will be the stopping potential here now. So this is your one frequency F1, and this is your another frequency, it is F2, right. So this is your another frequency, it is F3. So this is VO1 negative, therefore VO2 negative, VO3 negative. So that means what you can understand now from this graph, no. So you understood that therefore as this frequency is increased now, that means here F3 is greater than F2 is greater than F1. Frequency is increased, so what happened now? Stopping potential is increasing now. So that means as the frequency is increases, therefore stopping potential is increasing. Stopping potential is increasing means what? Kinetic energy is increasing now. That means frequency showing the effect on the kinetic energy now. Therefore, so here kinetic energy of emitted electron, or we can write down stopping potential, so or cutoff voltage, stopping potential. So it is purely depends on frequency only. These are the 4 points, so which you are observing in the photoelectric emission onto this. Ultimately the conclusion was what? Only these are the 4 points of this total explanation, total experimental observations now. What you can write it now? What is the 4 observations now? Emission of electrons is directly proportional to the intensity. So kinetic energy of the electrons does not depend upon the intensity. Kinetic energy of the electron depends on the frequency, and kinetic energy of the electron is independent of the intensity. That's all. Clear? So these are the observations, no. Now, so therefore, now the question comes now, how that electrons are emitting if the light is falling on that one now. That means if the light is assumed to be like in the wave nature, no, so wave will not show impact on the matter onto this one now. So therefore emitting of the matter, emitting of the electrons, compulsory, it has to be compulsory the particle, right. So particle only should be shown some effect, no, then only it will be emission will takes place now. So this was a strongly right suggested by our Einstein now. What this Einstein's now he explained, right. So Einstein's photoelectric equation. For this only he got the Nobel Prize onto this one, no. So what did he do now? He assumed that, he said that he believed the quantum theory. So he said that so light is a particle nature. Particle is what? Photon. Quantum theory. So we already studied about the photon detailedly. Please go through that video. All the different model questions, no, about the complete photon I explained about the radiation pressure and everything, no. So E is equals to h into F or hc by lambda or 12400 by wavelength in Angstroms. This is in electron volt. So these are the already we did, right. So very detailed video I did, no. Please go through it. Now he thought that he said that light is in the form of like a particle nature. So how we explain now? The explanation was very simple one now. Therefore here, so there is a one plate is there, no. This is one plate. Okay. So what happens now, upon to this plate, no, therefore we are going to incident one light. Therefore light is nothing but a h into f or hc by lambda, that is nothing but a photon. We already said that 12400 by wavelength in Angstroms in electron volt. This is your incident energy. This is the energy which is incident. Now this energy, what will happen now when electron was observed onto this one now from this atom, that electrons now what will happen now, it will go to excited state. So if they are getting certain amount of energy onto this one now, so it can overcome the bond of the nucleus, no, the force of the nucleus, no, therefore it will come out like a easily like a free electron now. So to emit that electron, no, therefore certain amount of energy has to be taken by the electron. So to jump from lower state to higher state, no, so for every metal there is a certain amount of energy is required to emit the electrons, no. So for this metal there will be having like a work function. What is this work function now? Work function is defined as, therefore, minimum energy required to emit the electron from the metal surface onto this, right? Minimum energy. This is called minimum energy. Clear? So that energy can be written as h into f naught or hc by lambda naught. So what is this f naught now? This f naught you can write it as like a threshold frequency. Threshold frequency. What is this threshold frequency? This is energy should be minimum, means frequency also should be minimum. That means minimum frequency we have to incident it, no? Minimum frequency we have to incident so that it is going to emit the electrons now. And this is inversely proportional, no? This is called like a threshold wavelength. Threshold wavelength. So therefore this is nothing but a maximum wavelength. Maximum wavelength which is required to emit the electrons onto this. Clear? So therefore here it is having some amount of work function, no? And this electron emission will take place. When it will take place now, very important condition. So when incident energy is greater than the work function or greater than equal, right? So minimum is equal, no? Therefore when the photoelectric emission will take place, no, when incident energy is greater than the work function, no, then only emission of electrons will be takes place. If it is incident energy is lesser than the work function, no, there is no chance of emitting the electrons, no, which is having directly proportional to the frequency. Therefore higher frequency will shows maximum emission onto this one, no. That's why ultraviolet rays is having the higher frequency onto this one, no, that are emitting the electrons very, very easily onto this. Clear? So energy should be greater than compulsory. If this condition is not satisfied, there is no chance. Simple thing, no? You understand, no? Therefore here energy of incidence should be greater than the work function now. Suppose it is very larger than this one, no? This emitted electron, no, will be moving with certain kinetic energy. Clear? So he used law of conservation of energy. This much is given, this much is falling, this much is taking, remaining energy is given as kinetic energy. So what he used now? He used law of conservation of energy. Law of conservation of energy. So Einstein photoelectric equation now is based on law of conservation of energy onto this. Clear? So what did he written now? There is a simple thing, no? So this much is given. So E is given, no? So this much is taken, phi, and remaining thing coming as like a kinetic energy. This is your Einstein's photoelectric equation. E, this only, for this only he got the Nobel Prize after this, right? So therefore then he also verified also. So we can rewrite it as, if they are given in terms of wavelength, here also wavelength, no, therefore in terms of velocity, all these formulas. What are these formulas? No, you can rewrite it now. Einstein photoelectric equation, what is this one? No? E is equals to incident energy phi plus kinetic energy. So E already we know that, no, therefore H into F. So in terms of H into F, no, or Hc by lambda. So this is your E. So this is your work function, no, H into F naught, that is nothing but Hc by lambda naught. This is your work function. This is your kinetic energy kinetic energy is nothing but a maximum kinetic energy half m v max square r E into V naught. So these are the formulas, no, whatever the things they are asking, no. So as per given data, you have to substitute, solve this one, no, you can get your answer very easily. Clear? So if they are giving frequencies V naught, you can use the formula. So we can rewrite it as one formula, no. Anything you can just substitute. These are the formula. That's all, right? Now, so this equation is valid if energy is greater than this one, no. Clear? So suppose we will write down therefore H into F. So therefore H into F naught plus E into V naught. Clear? So therefore you can rewrite it as here toward this side E V naught you can write down. So H into F minus H into F naught. This is work function. V naught can be written as H by E into F minus H into F naught by E. So therefore you drawn the graph here, no. Therefore how the graph it will be there? Y is equals to mx minus c. So therefore he plot the graph based on this one, no. So very important. This was your experimental observation. I mean confirmation, no. This is V naught and this side is x is nothing but a frequency. Right. So therefore what he observed, no, it will be a straight line but negative intercept is there, no. Therefore how the graph it will be there? So the graph it will be like this. Clear? So this is for material A. Suppose another one more material we are taking now, therefore it will be the B. So what will be the intercept here now? Therefore you can rewrite it as this, it will be your work function by E. Clear? Clear? Now for material A, so therefore work function by material B by E. So what you can understand now? What you can understand here now? So this slope is there, no? Slope is nothing but H by E. H by E. So this is theta. Therefore this is theta. So he calculated slope. Slope is equals to, he calculated the slope and substituted the charge of the electron. He got the Planck's quantum value onto this. That was the proof for this equation onto this one. So but what you can understand now? Slope is nothing but a tan theta, that is nothing but a H by E. So for any material the slope was constant, slope is same. So what will be the slope here now? Therefore you can calculate it now, you can remember this value. So 6.63 into 10 to the power of minus 34 divided by 1.6 into 10 to the power of minus 19. So how much will get it now? Taken top 19 means minus 15. So 6.6 4.1. So nearly 4.1 into 10 to the power of minus 15. So remember this value. So because H by E value, no, sometimes calculation it will be useful, no. 4.1 into 10 to the power of minus 15. This is your slope of this one. Slope is constant for all the materials. Any material, if you draw the graph, no, V naught in frequency, the slope is constant. Slope is same. Clear? So here what is this one and this value is no. Okay, what you can understand here this one, no. Therefore what you can understand from this one now? So work function of A is smaller now. Therefore what you can understand? Work function of A is smaller than work function of B. So that means what? A less amount of energy is required to emit the electron from the material of A. But for B, large amount of energy is required to emit the electron because work function is larger onto this one now. So easy emission will not take place, no. Easily the emission will be takes place, no. That's why this type of material is used for some photovoltaic cell, no, or the solar cell onto this one, no, like that. Clear? So this is one point. Next point, what is this point now? Therefore here, right. So this is your what you can understand here now. It is a positive intercept now. So which one will becomes to the 0, 0 this one, no, H by H by. Therefore these are the values, no. So it is a threshold frequency of A and this is the threshold frequency of B. So if you know the threshold frequencies, no, you can calculate threshold wavelength and work function very easily onto this. Clear? Threshold frequency of A is smaller, no, again. So threshold frequency of A is smaller than threshold frequency of B. Clear? So like this observations no, you require to learn about these concepts onto this. So in this way he explained about all these concepts no. This is the where foundation was taken place no for quantum theory onto this, right. So it's a experimental proof onto this. So then we came to know that light is in the form of like a particle nature onto this, clear. So this also supporting. Later on we came to know the de Broglie wavelength, that also I discussed in the one video, right. So let us do some simple questions onto this one no. So which are frequently asked in the examination point and different models no, we'll see. Let us see some questions onto this one no, very easily you can solve it. I think it is not visible. Okay, I will explain it no, just concentrate on my words no. There is a threshold wavelength is given now. Threshold wavelength. What is the threshold wavelength now? Lambda naught is given. How much now? 400 nanometer. And so photoelectrons is having kinetic energy. Maximum kinetic energy is given as 1.5 electron volt. Right? Is asking what is the wavelength is incident photon. Wavelength of your incident photon. Clear? So first of all, let us calculate. You can use so many ways no, but I will try to solve these problems no by using like electron volts only, so that it is easy calculation no. So this is here, you can write it as 4000 angstroms no. So this I can write it as work function. So what is the work function now? Therefore 12400 by wavelength in angstroms, this will get in terms of like a electron volt. How much will get it now? 12400 by 4000 electron volt. Therefore these two zeros point here no. So therefore 2 therefore 6.2. So therefore it is 3.1. Therefore 3.1 electron volt. This is your incident, work function onto this one. So you can write down E is equals to work function plus kinetic energy. So what you can write it now? Work function is nothing but a 3.1 plus 1.5. So this are electron volt no, 4.6 electron volt. This is your energy which is incident. But we want to calculate the wavelength of this incident no. So same thing, same formula again you can rewrite it as. So therefore here wavelength in angstroms, we can rewrite it as 12400 by energy is in electron volt. Clear? I think you understood this one no. Therefore how I written this one now by using this formula. Clear? Now 12400 divided by 4.6. So here you can rewrite it as, so 12400 divided by 4.6. So therefore 2695 angstroms. 2695 angstroms. So this is our wavelength no, which is incident no. So even you can solve in different methods also. So right, you can solve it very easily. Clear? So next one now, let us go for this one more question now. I think, right? So here therefore there is a work function is given no. So what is the work function is given now? Work function is given how much now? 2.3 electron volt. So wavelength of incident photon, wavelength is given how much now? 4.8 into 10 to the power of minus 7 meters. I want to write down in terms of electron volts only. Therefore what you can write it now here? So therefore 4.8, or I can multiply 4.8 into, I can multiply 1000 into 10 to the power of minus 10, I can write it. Clear? So therefore what I can write it now? 4800 angstroms. So this is your wavelength is incident. So he is asking what is the maximum kinetic energy. Very simple one now. Therefore first of all incident energy we want to calculate, energy which is incident no. So we know it 12400 by 4800 electron volt. Clear? These two zeros no. Right. So here, so you can rewrite it as here 124 divided by 48, 2.58 electron volt. So, what is the kinetic energy now? E is equals to 5 plus K. So, therefore, K is equals to E minus 5. E is how much now? 2.58 electron volt minus 2.3 electron volt. What you will get it now? 2.30. So, therefore, 8. So, this is 0.28 electron volt will be your kinetic energy of this one. Suppose they may ask you what will be this is the kinetic energy. From this one now they may ask you what is the maximum speed onto this one now, they may ask you what is the momentum onto this, or they may ask you de Broglie wavelength associated with this one now. These all the things no you can calculate it no. So, I already did all the photon type of problems and de Broglie wavelength problems no. So, from here you can frame anything. That is what the physics no. You cannot depend on only one type of model questions onto this or no. From that also there is a hundreds of questions can be created onto this, right. So, now let us go for one more question here now. So, here I think it is visible. So, here one logical question it is asked now. So, light quanta with energy. So, this is a energy of incident energy is given how much now? 4.9 electron volt. So, eject the photoelectron from the metal with a work function. Work function is how much now? It is given as 4.5 electron volt. So, find the maximum impulse transmitted to the surface of the metal when each electron flies off. And one more important point now. So, here emission of electrons no will not takes place much time now. Therefore, electron emission no which will be the very instant onto this, right. So, immediately when light is falling, immediately the electrons will be emitted onto this, right. So, that is you can remember. So, here, so what is happening now? This one plate is there. So, upon to that there is a light is falling onto this. When light is falling onto this sun now, therefore, what is happening onto this? What is the momentum? Impulse is asking impulse. Impulse means nothing but a momentum. So, we want to calculate the momentum on this plate onto this sun now. So, here what is the momentum of the plate now? Therefore, here there is a photons which are incident onto this. Photons also will exert the certain amount of momentum. So, therefore, for this one now there is a momentum is given, photon momentum of the photon, plus if an electron is emitted, this electron is having certain momentum. So, initially there was at rest no, like our already studied, when one nucleus is there, one bomb is there no, therefore it is at rest no, when it is exploded, so make into two parts no, therefore the momentum of this part will be the same. Similarly, so electron was initially it was inside onto this no, when electron is emitted, so what is the momentum of the electron which is there, that much amount of momentum is imparted to this one no. Therefore, for this plate momentum of the electron. So, this much amount of momentum will be gained by the plate onto this, clear? So, now first of all we can calculate what will be the momentum. First of all kinetic energy of the electron, will see kinetic energy of the electron. What is the kinetic energy of the electron now? So, you can see it now, very easily you can solve it now. So, kinetic energy it will be equal to E minus 5. So, subtract this to 0.4 electron volt will be your kinetic energy of this one. Kinetic energy of the electron here, clear? So, when electron is kinetic energy, so therefore momentum now. Therefore, what will be the momentum of this one now? Momentum gained by this one now. So, see impulse means what? Impulse means so change in momentum now. That is nothing but a momentum of the photon plus momentum of the electron. So, what you can write it now? Momentum of the photon, what you can write it now? So, momentum of the photon E is equals to mc square means E by c. So, plus momentum of the electron, kinetic energy you know it now. Therefore, kinetic energy means 2m into kinetic energy of the electron, clear? So, E is how much now? E is what? Energy of the photon. What is the energy of the photon? 4.9 electron volt. 4.9 into 1.6 into 10 the power of minus 19. So, divided by 3 into 10 the power of 8 meter per second plus root, therefore, 2 into mass of the electron 9.1 into 10 the power of minus 31 into kinetic energy of how much now? 0.4 into 1.6 into 10 the power of minus 19. So simplify, you can get your answer onto this. I think therefore this is a just mathematical solve onto this one. Therefore you can solve it, right? But here this is slightly important one now. Understood? So what will be your answer now? Therefore I will be simplifying and I will keeping the answer here now, right? So just mathematical thumb no. So therefore I already simplified here no. Therefore nearly you will get it a 3.43 into 10 the power of minus 25 kg meter per second. Sorry, here kg meter per second. Yes. Yeah. So this it will be your answer onto this. Clear? So in this way you can solve the problems. No. Now let us see one more important question. No. So stopping potential. Okay, I'll show this one. No. Right. There is a stopping potential of the photoelectrons emitted from the metal surface. Stopping potential is stopping potential is given. So what is the stopping potential? No, 10.4 volts. So what will be the kinetic energy here? No, kinetic energy is nothing but a E into V naught. So 10.4 electron volt. This is your kinetic energy. What is the work function here? Now is given as 1.7 electron volt. So find the wavelength of radiation used. So you know in energy you can write it as so 5 plus k. So 1.7 plus 10.4. 10.4 is huge. Okay. So what you can write it now? Therefore here it will be 7. Therefore 11 1. So 1 means 2. So 12. Right. So right. So 12.1 electron volt onto this. Clear? So wavelength we want to calculate. Again wavelength is in angstroms. You can write down 12375 actually. So energy is in electron volt, therefore in angstroms. So therefore 12400 divided by 12.1 in angstroms. Right? So here you can write it, you can get it as how much now? 1024 angstroms. This is your wavelength which is incident on this metal onto this one. Clear? So also identify energy levels in the hydrogen atom which will emit this wavelength. Okay, this wavelength you should get it, no? Therefore, what should be the transition should take place onto this. Clear? So this is comes under like a Bohr's atomic model onto this one, no? So but we did not discuss onto this, right? So okay, you know it, no? 1 by lambda is equals to therefore R into 1 by n1 square minus 1 by n2 square. Clear? So therefore here you can solve it, no? From which one and to which one. So actually here energy is this one 12.1. Actually 12.1 means a hydrogen atom, no? Therefore this is here 13.6, no? So this is 3.5. So therefore here it will be 1.5. So 1.5 means here 1.5 to this one means, so you will get it as 12.1. Therefore n value is equals to 1, 2, 3. 3 to n is equals to 1. Therefore you can solve it very easily. The transition should be takes place from, so n value is equals to 3 to n is equals to 1. So this is only the possible one now. So the transition should takes place in this one now. So when I am discussing these atoms, no, I will discuss very easily. So right. So in this type of questions also you can use this also. Calculation is lengthy, but if you remember this energy level diagram, no, it is very simple onto this. Clear? No? Right. So that's why you should keep the notes and start copying onto this one. No? Whenever there is any important information you got it, no, just please note down onto this. Clear? Now let us see one more question now. I think it is visible. So if the question is not visible, please don't worry. So you just focus on what I am explaining onto this. So therefore here a light of wavelength is given, no? Therefore wavelength is given, okay. So a light of wavelength, it is incident, no? Therefore how much, no? 1240 angstroms, clear, is incident on a metal, therefore threshold frequency is given, no? Threshold frequency, therefore 4.8 into 10 to the power of 14 hertz. What is the maximum kinetic energy of the photoelectrons onto this? Okay. So anyway you can solve it, no? Frequency means again you can calculate. So phi naught, you can calculate, this is your incident, E is equals to 12400 by wavelength, right? How much it will be now? 12400 by 1240, so electron volt, that means you will get it as nearly, therefore 10 electron volt, clear? This is your H into F naught, right? So this it will give us in terms of like joules, no? And divided by E, also you can calculate it now. So what you will get it now? Therefore 6.63 into 10 to the power of minus 34 into 4.8 into 10 to the power of 14. This is in terms of joules, you will get it now. So you know 1 electron volt is equals to this joules, no? 1 joule is equals to, or therefore 1.6 into 10 to the power of minus 19 electron volt, clear? Huh? So we will solve this, how much you will get it, no? We will see now. Right, I think you are getting 19, so nearly 2 electron volt I am getting here now, clear? Nearly. So what will be the kinetic energy now? Kinetic energy is nothing but E minus 5, so therefore, sorry, 10 minus 2, therefore 8 electron volt will be your kinetic energy of this one. Even in terms of joules, no, multiply with 1.6 into 10 to the power of minus 19. Next, one more question is also added. Light of intensity is given, no, and calculate the number of photons. I already discussed here. Intensity is given, no, right? This same question, no, I discussed in the photons concept, no. Please go through it, no. So those who did not see, please go through it. It's a very important chapter topic onto this, no. Intensity, what I discussed now, intensity, I will discuss one more time, no. Intensity is equals to amount of energy per unit area per unit time. So this is for total energy, number of photons. Therefore, number of photons emitted per unit area per unit time can be written as like a intensity by energy of the photon. Energy of the photon. Energy of the photon should be in terms of like a joules. Intensity is given how much now? 100 watt per centimeter square. 100 watt per centimeter square, he gave it is in terms of meter square. So centimeter square means 10 to the power of minus 4. So taken top, no, therefore 10 to the power of 4 here, no. So by energy of the photon, incident, you know, therefore here incident energy. So incident photon onto this one, 10 into 1.6 into 10 to the power of minus 19. So therefore this is 0, no. So 1 by 1.6 means, so 6.25, you can write it, no. So actually 1 by 1.6 means 0.625 actually. So that means you can get it as, so this is 0.625, this 1 by, so taken top, no, 10 to the power of 5 plus 19, this is 24, one taken, you know, 6.25 into 10 to the power of 23 photons per second per unit area. Right, clear? Now let us see. Yeah, this type of questions no frequently asked in the examinations no. So right, very simple questions no. Let us see. I think it is visible. So a certain metallic surface is there, is illuminated with a monochromatic light of wavelength. There is a one metal is there. So upon to this one no, for this one wavelength it is there no. The stopping potential was observed that it is 3 V naught. If the same surface is illuminated with a 2 lambda, the stopping potential was what? V naught. He is asking what? Threshold wavelength, lambda naught is asking, that's all. Simple question. So no need to study all this one no. So when lambda is incident on a metal surface, 3 V naught was the stopping potential. So on the same plate no, 2 lambda was incident no, V naught was stopping potential. That means what will happen now? Wavelength is increasing means frequency is decreasing, means energy is decreasing. Energy is decreasing means what? So kinetic energy is also decreases. Clear? So we will write down the equation here now. So what is that equation now? Therefore E is equals to phi plus K. Okay. So therefore here you can rewrite it as Hc by lambda for this one no. So therefore Hc by lambda naught we want to calculate plus, so therefore 3 E V naught. Clear? Kinetic energy. This is one equation no, or you can rewrite it as therefore Hc taken common no, 1 by lambda minus 1 by lambda naught, it will be equal to 3 E V naught. This is one equation now. So for this second equation also you can write down Hc and 1 by 2 lambda minus 1 by lambda, so is equals to E V naught. So this is your second equation now. So what you can do it now, just simply you can divide these two equations now. E V naught cancel, Hc and Hc get cancelled out onto this. Clear? So 1 by lambda minus 1 by lambda naught, so taken toward this side now, 3 times of 1 by 2 lambda minus 1 by lambda naught. So now right, multiply it now, therefore 1 by lambda, this is 3, so therefore here it is taken here now minus 3 by 2 lambda, so is equals to minus 3 by lambda, this is plus 1 by lambda naught. Clear? So just mathematics, right. So here you can write it now, therefore here 2 I can multiply, 2 means minus 1 by 2 lambda, it will be equal to therefore minus 2 by lambda naught. So lambda naught it will be equal to 4 lambda. This is your answer. So first option will be your correct answer. Clear? Very simple question no? Yeah, exactly the same type of question no? First understand the question very easily, so that once you understand no, just substitute the concepts, right. If it is not visible also don't worry, just visible. When two monochromatic lights of frequency, so there is a frequency mu is given now and mu by 2 are incident on the photoelectric material. The stopping potential was becomes like a, when this one is become like a, so Vs by 2 or this is nothing but a Vs. Right. So threshold frequency we want to calculate, therefore threshold frequency, clear, right. So we want to calculate it now. Okay. So frequency, what you can write it now, again the same formula, phi plus k, these are the stopping potentials now, clear, right. So this is taken here now, so h into f. So frequency of this one is how much now, mu and mu naught, it will be equal to E into Vs by 2, clear. So for the second one we can rewrite this equation now, h into, so mu by 2 minus mu naught is equals to E into Vs. So what I can do now, therefore just I can divide these two, h and h cancel, So EV here get cancelled out onto this. Clear? So this is 1 by 2 you will get it, no? Mu minus mu naught, it will be equal to, so this is 1 by 2 means this side 2 will get it, no? 2, this side mu by 2 minus mu naught. Clear? So multiply it, no? 2 mu minus 2 mu naught is equals to mu by 2 minus mu naught. This taken here, this taken here. 2 mu and mu by 2 is equals to 2 mu naught minus mu naught. So therefore here mu naught you can write it as 4 minus 3, therefore 3 mu by 2. This is your threshold frequency onto this. 3 by 2 mu. This is your answer. Clear? Right? Next. Right. Now, right, a photometal is illuminated by the lights of wavelength lambda 1 and lambda 2 respectively. The maximum kinetic energy of electrons emitted in the two cases E1 and E2 are respectively. So find the work function of the material. Work function we want to calculate now. Work function, what you can get it now? So E minus K. Clear? So therefore work function, what you can write it now, right? Work function means, so okay, what you can write it now? Therefore here it is E is nothing but a, or we can rewrite it as, we can use standard formula only. So E is equals to phi plus K. So E is nothing but a Hc by lambda 1 is equals to phi plus E1. Clear? Now Hc by lambda 2, therefore phi plus E2. So just divide these two equations now. So what you can get it now? Therefore this Hc and Hc get cancelled out now. Therefore lambda 2 by lambda 1, this it will be the reverse. So phi plus E1 by phi plus E2. Just cross multiply it, no? So therefore phi lambda 2 plus E2 lambda 2 is equals to, so phi into lambda 1 plus E1 lambda 1. So this taken here, no? This taken here, no? Right? So here what you can write it now? Phi into lambda 1 minus lambda 2, this taken here, no? E2 lambda 2 minus E1 lambda 1. So work function it will be equal to E2 lambda 2 minus E1 lambda 1 by lambda 1 minus lambda 2. So will be your answer. Yeah, fourth option will be your correct answer. Yeah. Clear? Huh? Now let us see one more question. No? These all are I think you understood, no? The model of questions, all these one, no? It will be the easiest one, no? So light of frequency, there is a frequency is given, incident on the metal surface, no? Electrons with a maximum speed is given, no? Are ejected from the surface. What is the threshold frequency of the photoelectric emission of the electrons? Threshold frequency, what is asking now? So therefore what is given now? Incident light, therefore frequency of this is given now 7.21 into 10 to the power of 14 hertz. So maximum speed is given now 6 into 10 to the power of 5 meters per second now. Therefore here it will be F naught is asking. That's all. Therefore okay, so here again the same formula here, no? So here work function, that is nothing but h into F naught is equals to h into F minus half mv square. Clear? So taken here now, F naught, if you divide it now, F minus, so kinetic energy, so half mv square by h. Clear? So F is given how much now? 7.21 into 10 to the power of 14 minus, right? So here mass of the electron is 9 into 10 to the power of minus 31. Velocity whole square means 36 into 10 to the power of 10 divided by h value is 6.6 into 10 to the power of minus 34. Clear? Taken now, therefore it will be 34 means 3. So therefore here 7.21 into 10 to the power of 14 minus, so this is 1, therefore we will do this calculation, no? Right. So here 9 into 36 equal to divided by 6.6, 49 into 10 to the power of 13. So or we can write down 4.9, therefore 4.9 into 10 to the power of 14. So you can rewrite it, subtract it, no? Therefore 4.9, so 7.21 minus 4.9, so therefore 2.31 into 10 to the power of 14 hertz. This is your answer. Clear? Right? Now let us see. There is a work function of certain material is there now. Therefore, here there is a work function is given. How much now? 4.2 electron volt. Will this metal gives us a photoelectric emission now if it is incident with a wavelength? Wavelength is given how much now? 330 nanometer. Therefore, 3300 angstroms. Clear? So energy we have to calculate it now. 12400 by 3300 electron volt. 2 zeros, 2 zeros. So therefore here now we'll see 124 divided by 33, 3.75 electron volt. So this energy, whatever the energy is incident, is very less than our work function now. Is less than our work function now. Therefore photoelectric emission will not occur. Clear? Clear? Now let us see. This is one of your NCERT example question. No? So there is a work function of the cesium is there. No? Cesium is given. So threshold frequency, simple. Therefore wavelength of the incident light of the photon is brought to 0 by the stopping potential now. Okay. So first let us go for this one, no? Work function. No? So work function is given how much now? So 2.14 electron volt. So is asking what is the threshold frequency. Therefore here it will be, so F naught it will be equal to work function by H, 2.14 into 1.6 into 10 to the power of minus 19 divided by 6.6 into 10 to the power of minus 34. Clear? So that means 2.14 into 1.6 divided by 6.6. So you will get it as 0.5. So many are there. So you take it as now. Therefore plus 34 means 15. Or you can write it as directly 5 into 10 to the power of 14 hertz. Clear? So the wavelength of incident light, if the photocurrent is brought to 0 by the stopping potential. That means here he gave kinetic energy directly. What is the kinetic energy? 0.6 electron volt, 0.6 no. So E V naught. Therefore here 0.6 eV electron volt. Clear? So this is your work function. No? Wavelength of incident light. First of all, incident energy we have tried it. No? So 5 plus kinetic energy. So 2.14 plus 0.6. How much now? 0.6 means 0.60. You can write it now. Electron volt. So this is for 2.74 electron volt. Clear? This is your incident energy. So just you can rewrite it as, so E is equals to 12400. Okay. Therefore direct wavelength, no? Wavelength in angstroms by therefore 2.7 electron volt. Clear? 2.74. So therefore 12400 divided by 2.74. So 4525 angstroms. 4525 means they may ask you which spectrum also. Mostly it is like a visible spectrum onto this one. No? So nearly violet and blue range it will be there. This. Clear? Yeah, one more question. No? Therefore here actually there is a graphs are given. No? There is a question, I will tell you. No? What is this questions? No? You observe these graphs. No? Therefore we want to calculate what will be the threshold frequency of A. So threshold frequency of A. What is the threshold frequency? Here it is intercept is there. No? This is the threshold frequency. How much now? 5 into 10 to the power of 14 hertz. Threshold frequency of B, what is given now? Therefore, so 10 into 10 to the power of 14 hertz. Right? You can calculate the work function here now. Work function of A, H into F naught of A. Multiply this one now. Therefore, 6.6 into 10 to the power of minus 34 into 5 into 10 to the power of 14 hertz. So therefore here 14 means 10 to the power of minus 20. So therefore it is 5 6 are 30, 3, 30 means 8. 80. No. Therefore here what you can write it now? 33. So 30, 0, 3. 33. So 33 point. Okay. This is your joules. Clear? So in this way they may ask you, or threshold wavelength also they may ask you. So many different concepts. No, they may expect it. Right, students? I think I covered most of the concepts. No. So right, if some multiple concepts are there like a photoelectric effect, de Broglie wavelength, photon. Still some mixed concept which are involved in a IIT Advanced. No, therefore I will discuss. I will come with one more video. But these all are the concepts. No, so regarding the photoelectric effect now, right? So thank you for watching. Please subscribe to my channel.